Hello everyone, my name is Abhishek and welcome back to my channel. Okay, so the first and the foremost thing. So there are multiple points that I'm going to cover, and the first and foremost thing that you have to make sure to secure your Kubernetes cluster like a pro is secure your API server. Okay, I'll cover about each and every point. Don't worry. The second point that you need to do to manage Kubernetes like a pro is you have to be very good with your Kubernetes RBAC. Okay. The third thing is, as a DevSecOps engineer, you have to ensure that your Kubernetes cluster namespace network policies are very well defined. Okay. What are these network policies? I'm going to explain. Okay. Then you have to ensure that the information is encrypted at the rest, that is in the etcd, because every Kubernetes object end of the day gets saved in the etcd, right? So you have to encrypt the objects. Why? And I'll tell you that as well. 5, use secure container images. This is again a very important topic. I'll tell you how to ensure that the container images are secure as well. Then cluster monitoring. And finally, you have to do frequent upgrades. So let us talk about each and every aspect of it. But on a high level, these has to be your top 7 priority points. That is, you have to secure your API server. Why? I'll tell you. How? I'll tell you. Don't worry about it. Second, RBAC. Third is network policies. What is network policy? Why is it required? I'll tell you. Fourth, encrypt the data at the rest in your etcd. Secure container images is must and should. You have to do cluster monitoring. You have to do constant and frequent upgrades. Okay, let's talk about each and every topic here. The first point. Okay, what is the first item that I told you? The very first thing is to secure your API server. Now, what is this? Securing the API server. So if you remember our previous Kubernetes video, I told you that in Kubernetes, you have this architecture, right? You have a master and you have your Kubernetes workers. So if you are dealing with production Kubernetes clusters, usually you have 3 master nodes, right? And you can have any number of worker nodes. Why you need 3 master nodes? Because to achieve high availability in Kubernetes, what is high availability? For example, if your Kubernetes master is going down, this can happen, right? You can create your master in AWS, you can create anywhere. Your master can go down. For instance, if your master has gone down, you need a high available environment that can be achieved by using 3 master nodes in Kubernetes. Okay. So let's say you have, for example, you have 1 master node and you have 2 worker nodes. Okay. So now what is securing the API server? So this is a user. Let's say this is a user called Abhishek. And what Abhishek wants to do is he wants to get some information like kubectl get pods. Okay, so what does this do? What does this request called kubectl get pods do? So kubectl is your Kubernetes command line, which will talk to a component in the master called API server. Right now, let's say this user, instead of kubectl, he's trying to access Kubernetes using the API calls. Again, what he will do, even if he's trying to access or get information of Kubernetes using API or REST calls, he will interact with the Kubernetes API server itself, right? So end of the day, anybody who wants to get any information from the Kubernetes worker nodes or from the Kubernetes, the request has to go from the API server. So what is your first point of entry in Kubernetes cluster? For any person, whether he is doing from the CLI or whether he is doing from the API, the first point of contact in Kubernetes is always the API server. Okay. So now, whether it is a good user, whether it is a bad user, whether it is a hacker, so everybody should get into the Kubernetes cluster through the API server. Okay. So unless he is trying to access the pods, using the load balancer or something, but for any general request that you are trying to do, you get through the API server. Now, because this is the first point of entry for hackers or for any particular person. So this API server has to be very secure, right? If the API server is not secure, what will happen? Like, let's say you have a HTTP website and you have a HTTPS website. Which website would you choose? You will always go for HTTPS. Why will you go for HTTPS? Because HTTPS says that this website is secure. Similarly, if your Kubernetes API server is not secure, right, what can happen is your Kubernetes cluster itself can be compromised. Okay, why it will be compromised? Because for anybody who is trying to access your Kubernetes cluster through the API server, they can easily enter because your Kubernetes API server is not secure. So what you have to do, you have to, as a DevSecOps engineer, you have to secure your Kubernetes API server. Okay, now how do you do that? Okay, you understood the concept that you need to secure your Kubernetes API server. But how will you secure your Kubernetes API server? Right? So it's not a rocket science. Like, if you have access to your Kubernetes clusters, okay, what you usually have to do is Kubernetes API server, right? Which is kube-API server. So this is generally a pod, right? In Kubernetes, every resource is a pod. So your Kubernetes API server is also a pod. So what you have to do is inside the pod.yaml. Which pod.yaml is this? The Kubernetes API server pod.yaml. What you will do is, as a DevOps engineer, you will secure your Kubernetes API server with some TLS secrets. Sorry, TLS certs. What is this TLS certs? It is nothing but your TLS certificates. Now, for your very basic understanding, today if you go to google.com, what you will usually do, https, right, /google.com. Now, what you will see in the browser is you will see a lock symbol besides this, right? For any website that you are using, opening using HTTPS, you will see a lock symbol. What is this lock symbol? This lock symbol is nothing but the certificates. Okay, so these certificates can be of two types. One is, it can be a self-signed certificate, or they can be certificates that you can purchase from any certification authorities, like, you can get them from GoDaddy, or you can get from any particular site. So similarly, to secure your Kubernetes API server as well, what you will do is just simply go to the Kubernetes pod API server, right? How will you go there? You can simply use the command called kubectl get pods, right? You can simply say kubectl get pods followed by the name of your pod name of your API server. If you don't know the pod name, you can just say kubectl get pods -a, and you can grep with the kube API server. So the pod name is usually like this, kube-API server. Okay, so this is the name of the pod. Just find this pod, and what you will do is, usually this pod is like, by default it can be in any namespace like kube system. Okay, let's say this is in the kube system namespace. So you'll go to the kube system namespace, you'll find this specific pod called kube-API server, and you will simply modify the YAML file. You can use the kubectl edit command, and what you will do is, there will be bunch of commands already. So if you know the pod, how will the configuration look like? Spec, and inside that it will look like containers. And here what you can do is, you can pass your TLS certification, TLS cert file. Then you can pass your private key. Then you can pass your client, that is your CA file. Okay, so these are the things that you will pass. You will know more about this when we do the live demo. So we can create one X509 certificate, which is self-signed certificates, and we can pass to the kube API server, so that you understand how to secure your Kubernetes API server. But end of the day, on a very high level, if you are talking about the theory, just go to the kube API server pod, and inside the pod you can add the certificate. So this can be self-signed certificates, or this can be custom certificates from any certification authority. Okay, so this is one way of securing your Kubernetes API server. Okay, so the other way to secure, like part B of the same topic, is, okay, you have done the TLS certificates and you have secured. The other thing that you can do is restrict the access. Okay, what is the other thing? So this is part B of the same topic, that is secure API server. And don't worry guys, the entire thing I have put in the GitHub page, so you can understand the same thing by following the GitHub page as well. But you will also have to restrict the access. So how will you restrict the access? It is very easy. In Kubernetes, there is topic called RBAC, right? So what is RBAC? RBAC is nothing but role-based access control, right? So what is role-based access control? Name itself is telling you that depending upon the role, only you will be able to access anything in the Kubernetes. So it is basically done by using three components in Kubernetes. That is the service account, role, and role binding, right? So using this also, what you can do is, let's say there is a user called, for example, let's say there is a user called XYZ. Okay. Now you don't want, or you want this specific user called XYZ, only this specific user should access the Kubernetes API server. So what you can do is, for this specific user, okay, you can create a cluster role, or you can simply create a role. And inside this cluster role, what you will say is this specific person, right, has access to, inside the resources, you can say, okay, inside the resources, you can simply say he has access to the pods, and that pod, basically you can provide the namespace of the pod, and he will be able to basically get, watch, and list. So using the role-based access control, you can also limit the access to the Kubernetes API server. So if you haven't understood this part, how to do it, like if you don't have proper understanding of Kubernetes RBAC, don't worry about it. When we talk in the future video in our free DevOps course also, we will be talking about RBAC. There you will understand how to use RBAC to restrict access. But you know, end of the day, just understand that to secure API server, there are two things, one and two. What is one? Like I told you, as part of one, you basically use the TLS certificates, or you use any custom or self-send certificates and pass the self-send certificates to your Kubernetes API server pod. And the second thing that you do is restrict the access using RBAC. Okay, so these are the two things that are required for securing the API server in Kubernetes. Now, point number two. What was the point number two that I told you early? Is using RBAC. Now, let me talk about RBAC in detail, because anyways, like I told you, we will be talking about RBAC in the future videos. But okay, because we are here, RBAC is nothing but role-based access control. Now, what is this? Like, this is a very simple concept. If you try to understand this using the requirement, why is it required, you will be able to understand this in 2 minutes. So let's say this is your Kubernetes cluster. Okay. So now in your organization, there will be developers, right? There will be people who are testers. There will be people who are managers. There will be people who are like, DevOps engineers. So how will you define, or how will you decide which particular group or which particular user? Let's say your organization has 10,000 users. So how will you decide which user has how much amount of access on this Kubernetes cluster? Okay, now you don't want your managers, or you don't want your testers or developers to delete something from the Kubernetes cluster, because they might not use their access in a efficient way. Probably they don't know which resource to delete. They might think that they are deleting the right resource, but they might delete the wrong resource. Okay, so how do you define which people have how much amount of access on the Kubernetes cluster? So for that, the simple concept is role-based access control. You can compare this with IAM on AWS, okay, identity and access management in AWS, or you can also simply compare with users and groups, right? Even on your Linux machines, you have the users and groups, and there you can say, okay, this user has only access to this specific files, this group has access to this specific file. Similarly, in Kubernetes also, you can define this specific access permissions using role-based access control. So this is a very, very important topic for DevSecOps engineers or DevOps engineers, because as DevOps engineers or DevSecOps engineers, it is your primary responsibility to define proper RBAC for the service accounts and for the users. Okay, so the simple difference between service accounts and users is that service accounts are usually the accounts, like for example you are using Jenkins or you are using anything. So for example you are using any third party application and you are using any pods or you are using any deployments. So these are the things that are not users, right? So they are basically services, and for services you can provide access. Like even sometimes your Kubernetes pod might require access to a config map because it wants to read some information from config map. Okay, so this kind of things are nothing but your service accounts which require access to some resources on your Kubernetes clusters. So in such cases you will use proper RBAC for the service accounts, and the other case is nothing but your users. What is users? Users are nothing but like you, me, or any person in your organization who wants access to the Kubernetes cluster. Okay, so you have to ensure that proper RBAC is given to service accounts and users. Okay, so you might spend days together sometimes. Okay, as a DevOps engineer you might spend some days together to properly configure RBAC, but this is very required. If you don't have proper RBAC configuration, okay, how you will do RBAC, I'll show you in the practical video, and in the future videos also in the free DevOps course we'll be talking about RBAC. Basically it comprises of two things. One is your cluster role, or basically your role, and the second thing is the role binding. Okay, using these two things, whether it is service account or whether it is user, you will define what is the role that is required and you will bind that role using the role bind. So this is a very high level. If you are not configuring your RBAC well, what happens is someone who does not have proper knowledge on Kubernetes, or someone who is malicious user, or someone who should not have access, he has access and he deletes some files on your Kubernetes and you will never get that files back. Okay, probably he's deleting your etcd, he's deleting your secrets, API server. Okay, so that's why your RBAC is very important and you have to configure the RBAC very, very well. So this is step number 2. And RBAC is just not for API server. It should be for all the resources in your Kubernetes. Okay, so you have to configure RBAC very well. Now, what is the third thing? So the third thing that I told you is basically the network policies. So network policies you will understand more when we do the practical demo, but it is very important for you to understand about the network policies. Like this is more like a practical topic than the theory topic, but I'll try my best to explain you why network policies are required. Okay, so let's say in Kubernetes you have multiple namespaces, right? In the last class I explained you what is namespaces in Kubernetes. So let's say this is namespace A, this is namespace B, and this is namespace C. So this is used by project A, and similarly this is used by project B, and this is used by project C. Okay, so each project or each namespace might have a different traffic flow, right? So in namespace A, you might have deployed applications that are only required within your organization. And in namespace B, you have deployed applications that are required by outside people of your organization. And in namespace C, you have mixed. Like, few applications are required inside your organizations and few applications are required outside your organization. So what you will do is, in this case, no pod has to be reached from outside the cluster, right? Let's say these are very secure applications. So in project A, you have information like the finance, or you have information like secure information or user database. Okay, very, very simple and mandatory use case is you have user database. Okay, so this pod will, if somebody is accessing this pod, they can get access to the user database. So this is a very secure thing. Somebody from outside your organization should not be able to access this pod, right? So you can configure network policies. Okay, so network policy is nothing but a resource in Kubernetes, and when you configure this network policy and when you attach this network policy to a namespace, nobody will be able to access, or access from outside. People might access the Kubernetes cluster, but they'll not be able to get any information from this particular namespace, because you have configured a network policies which says that nobody should be able to access, or you are limiting the access to this specific namespace of your organization, right? So this way you can save, or you can hide the user information, or you can basically hide any sensitive information of your organization. And sometimes your organization has very strict compliance rules. So all of these things can be handled using the network policies. But don't worry, you will understand network policies more when we do the practicals, because this is more like a practical topic than the theory topic. Now, what is the point number 4 that I told you? Encrypt data at the rest. So many people will fail to understand this topic. Theory itself, many people don't understand why this is required. So let me tell you, this is very, very important topic. This is your Kubernetes master. Okay. What is one of the important component of your Kubernetes master? etcd. Okay. Why is etcd very important? Right? etcd is nothing but etcd is a Kubernetes object store. Like, it's a key value Kubernetes object store. And what etcd does is it stores all the sensitive information. Like, it has sensitive information and all the Kubernetes object related information. Now, what is sensitive information? For example, in your Kubernetes, like, you have config maps, right? Similarly, you have secrets. Now, what is this secrets? Secrets is a place where you store sensitive information of your Kubernetes clusters. Like, for example, your pod requires any password, or your pod requires any TLS certificates, just for example, or your pod requires any encryption key, or your pod requires any API key. These are all the sensitive information that you put in secrets resource in Kubernetes. But end of the day, like I told you, etcd is your Kubernetes object store. You can consider it as every information of your Kubernetes cluster is stored in this etcd, right? Now, what happens if the secrets which you are trying to keep I told you that secrets is sensitive information. So as DevOps engineers, you have configured proper RBAC. So only good people, or only people who are required access to secrets. So you have ensured as DevOps engineer that your RBAC is very well configured, and all the information of the secrets are only given to right people in your organization. So you might think that your work is done till here, but like I told you, every information end of the day is stored in etcd. So now what a hacker will do, okay, so he firstly comes here, he'll try to access the secret, but you have blocked this specific thing. Like, as a DevSecOps engineer, what you said is, okay, you don't have luck, because I have blocked the access by using RBAC. So nobody will be able to access the secrets. Now, what the hacker will do is, okay, let me go and check etcd. So somehow he gets access to etcd and he'll read all the secret information. Now, what have you achieved with this? You have configured proper RBAC here, but what hacker has done is he said, I also learned Kubernetes. I know every information is stored in etcd. Now let me go to etcd and see. So he gets all the information from etcd. So this has to be solved. So what you need to do is, as DevSecOps engineer, okay, as DevSecOps engineers, you have to secure the information in etcd. So whenever any information, like let's say you have created a resource called secret here, okay, whenever this secret is going and get saved in the etcd, you have to ensure that in between there is a encryption mechanism. Okay, for example, you are sending a message to your friend over WhatsApp. What WhatsApp will do is it will ensure that there is a end-to-end encryption. So similarly, whenever this secret that you have created is getting saved in etcd, you have to ensure that as DevSecOps engineer, you have set up a encryption in between. So anybody, let's say the hacker, he tries to reach this secret, you will say this is blocked because I have RBAC. He'll try to reach etcd and he will try to read. He will not be able to read because it is saved as an encrypted key, and this hacker will not have the decryption key, right? So what he will get is, he'll get some information like if the actual password is abc, he'll get some information in the bytecode, or he'll get some information in a encrypted format that he'll not be able to decrypt. So this is how you have to ensure that you have a encryption configured for your etcd. Okay, now you don't have to do this for every resource. You can configure and say that, okay, whenever a sensitive information like secrets is getting saved in etcd, I have to create a encryption mechanism, and using the encryption key that I will create, the information in etcd is stored as sensitive information. So only people who have the decryption key will be able to handle the information or read the information from etcd. So this way you can secure your information in etcd as well as within your Kubernetes cluster using RBAC. Now how you will do it, I have clearly mentioned in my GitHub document that I have shared in the description. But if you want to wait till the practical session, that will be the next session, you can also wait for that session. It will be like 3 to 4 steps. Using this 3 to 4 steps, you can understand the entire concept. Okay, we will do with a practical demo as well, don't worry about it. Point number 5. So the point number 5 is you have to use secure container images. So I have put all of this information in the GitHub document. So if you are preparing for your interviews, if you are, if you want to pursue DevSecOps engineering in the future, you can use this as your notes. Okay. Whatever I have put in my GitHub document, you can use them as your notes, and you can definitely answer the interview questions. Okay. And using the practicals, you can try the practicals on your demo Kubernetes cluster itself, and you can become a pro. Now, what is this secure container images? So every day in the demos, you might be learning a lot of Kubernetes as part of your YouTube learning, or as part of your learning from various sources. Now you might be creating a lot of Docker images, for example. So in general, you are creating a lot of container images. Have you ever verified if these container images are secure? Okay. Have you ever verified, like, what you are doing is, as part of step 1, you are writing a Docker file, and within the Docker file, you are saying from Ubuntu, and then you are writing bunch of lines. Then you are executing it as part of your CMD or entry point. And now you are basically running your Docker image command. And then you are executing it using a Docker run, or you are executing as a pod in Kubernetes. So this pod gets executed on your Kubernetes cluster, and your end user who is trying to use on the production cluster, he is accessing this. Let's say, what if this container image that you have created here has a vulnerability? What is vulnerability? Like if you're using Android mobile, sometimes you will see that there is a new patch, right? Or if you're using any your mobile applications, TV applications, sometimes there are vulnerabilities, and what these people do is they release a new version and you have to upgrade the new version. Okay, so this update will be a mandatory version. Why this update will be a mandatory version? Because they might have found out some bugs. That is security vulnerabilities. Okay, but have you ever tried that on your personal laptop whenever you are creating these images? I think you have not done, right? So how to do this? So you have to always ensure that the container images that you are creating has to be secure. Let's say, even before deploying your application on the production, here itself you have identified that, oh, okay, the image that I've created using Docker image is not a secure image. So what you can do is you can go back and you can modify your base image, right? Instead of from Ubuntu, what you can do is you can use a specific version of Ubuntu, probably Ubuntu 22 LTS, or you can use a specific version which does not have these vulnerabilities. Okay, or you might have installed a lot of packages inside your container image, and one of these package, like probably you have installed make target, or probably you have installed using pip, you have installed request library, for example. Okay, and these libraries, the version that you have installed, have vulnerabilities. So what you need to do is, as DevSecOps engineers, in your CI/CD pipelines, or wherever you are creating these images, once the image is created, you have to use some tools like sync. Sync is a very simple tool, so I'll just tell you with sync. What you can do is, whenever you are creating this as part of your CI pipeline, you can add one more command called docker sync synk. This is not nc, sorry, synk, followed by, you can provide some arguments, or you can directly provide the container image. You have to provide the container image location. You should not provide the container image. You can try today after watching this video itself. You can try. Let's say your image is on Docker Hub. Do not provide your local image. Provide the image from Docker Hub or wherever you pushed, and simply use this command called docker sync. You can just say whichever severity as well. Probably severity high, followed by the image location. Probably it can be like, docker hub.io followed by Abhishek F5 followed by the container image location and the tag as well. Provide the tag as well. Okay. So once you run this command, most of the times your image will be vulnerable, because you are like, as part of this specific Docker images that you are learning, or as part of the Docker courses and Kubernetes courses, we basically do not put more information, or we do not put more stress on the from statement. Whatever the image that we have, we'll just directly say from Ubuntu. But this from Ubuntu might be the latest version, or it might be probably you're using from Ubuntu 18 or you're using from Ubuntu 19. So these might have some vulnerabilities. Okay. And we don't bother, as we are learning Kubernetes, or sometimes even DevOps engineers do not have proper knowledge, and they'll just say, okay, I use latest image, or I used some specific image, and let me push this image to production. But before that, you have to validate your image with any of the container security tools. Okay. So it can be Quay, it can be like, these are some of the things. You can either use Quay.io, you can use Sync, you can use Claire, you can use Trevi. So there are a bunch of things that you can use, and Sync is a very easy thing. Like, you can practice today at your end as well. Just use Docker Sync, and as DevSecOps engineers, you have to integrate this to your CI/CD pipelines. Okay. Don't worry, I'll show you this in the practical as well. Now, what is the point number 6? So the point number 6 is cluster monitoring. So how much ever you try to follow all of these things, okay? So let's say you followed all of the 5 points that I've given you. What happens is, let's say there is an end user who has created a pod in Kubernetes. Okay. So this is a developer. He has created a pod in Kubernetes, and what he is trying to do is he is trying to access some file called /etc/shadow. For example, this is a very secret file that nobody should access. Okay. So let's say your pod is running with a specific user. It can be root, or if it is running with root, there itself it's a problem. Let's say it is running with some user called Ubuntu, and this user, using the sudo, he is trying to access this specific file location called etc shadow. So he is trying to use this command sudo cat /etc/shadow, and let's say he got some sensitive information. He is trying to save this information on his personal laptop, on a notepad or somewhere, and this person can be a hacker as well. So how do you know, or how do you detect that this activity has happened? Okay, so as DevSecOps engineer, you should know, or you should understand that such activity has happened, and you have to take regarding action. Like, for example, if this person was able to do it, how did he do? Did he manage to do this using the root user? If that is the case, you know that no container should be running as root user on the Kubernetes clusters. There itself it's a problem. So you have to go and mitigate this action. If he is trying to do through the Ubuntu user, he has sudo access. Why is he doing it? What is his intention? How can you rectify, right? So to do all of these things, first of all, you have to be notified. So how do you get notified, or how do you understand all of these things? So there are very good cluster monitoring tools like Sysdig. Sysdig is a very popular one. Okay. So this is a free or open source tool as well. So what we will do is we will try to install Sysdig as DevSecOps engineers. And what this Sysdig does is it runs as a daemon set. So what is a daemon set in Kubernetes? The one that runs on each and every node of your Kubernetes cluster, and it will continuously watch for your cluster monitoring actions. So it will do cluster monitoring, and it will identify, like, it has some ML rules. It has some AI ML rules where it knows that, there are a bunch of things that should not happen on your Kubernetes cluster. Like one of the example I gave you, that nobody should run as root user, or no container should run or root user. Nobody should access some files like etc shadow. Okay. So Sysdig is a tool. If you install as DevOps engineer, you should definitely install these tools, and you have to use them for your cluster monitoring. Okay. What is point number 7? We'll do the practical of Sysdig as well. Don't worry. And the point number 7 and final one is you have to do constant upgrades. So this is valid not just for Kubernetes. This is valid for your Jenkins. This is valid for your, Ansible. This is valid for any tool that you are using. Terraform. So what you need to do as DevOps engineers is you have to ensure that the tools that you are using are up to date. Why they have to be up to date? Because if someone finds some vulnerabilities on these tools, what they usually do is they will patch the vulnerabilities and they will fix them in the latest versions. Okay, so as DevOps engineers, DevSecOps engineers, you should not use old version of Kubernetes. Like today, if the version of Kubernetes is 1.26, you should not be using 1.21, 1.20, because these old versions might have vulnerabilities. So always ensure that your Kubernetes cluster is up to date, and also your components in the Kubernetes cluster are also up to date.